For over 60 years, a mysterious and steady pulse has been beating deep within the Earth, a rhythmic tremor that repeats every 26 seconds. Now, the title of this video is Mystery Solved. But is it really? While other deep tremors can signal impending disaster, this particular heartbeat has been a stubborn enigma. But now, scientists are finally closing in on what causes our planet's hidden vibrations and what they reveal about the world beneath our feet. It's a phenomenon so subtle you can't feel it, yet so persistent it's been recorded by sensitive instruments for over half a century. This isn't the violent shaking of an earthquake, but a quiet, rhythmic tremor that has baffled the scientific community since its discovery. What is this constant planetary hum, and what other secrets are hidden in the deep, silent rumbles of our world? The story of Earth's heartbeat kicks off in the early 1960s with a researcher named Jack Oliver at Columbia University. While sifting through seismic records, he noticed something odd, a perfectly regular, low-energy tremor that stood out from the chaotic noise of typical geological activity. He described it as a worldwide storm of microseisms, too faint for any human to feel, but clear as day on his instruments. Oliver was able to trace its origin to somewhere in the equatorial Atlantic Ocean, and noted that it seemed to get stronger during the summer months in the northern hemisphere. But back in the 1960s, the tools to properly investigate this just didn't exist. Oliver was working with paper records, not the advanced digital seismometers we have today, and so his fascinating discovery was largely filed away, becoming a geological cold case. The mystery was picked up again in the 1980s when a USGS geologist named Gary Holcomb confirmed the pulse's existence and made another key observation. It became significantly stronger during storms. This link to weather added a new piece to the puzzle. But it wasn't until 2005 that technology caught up. A team of researchers at the University of Colorado Boulder, using a global network of modern seismometers, was able to triangulate the signal source. They narrowed the location of the heartbeat down to a specific region in the Gulf of Guinea called the Bight of Bonny, off the western coast of Africa. Knowing the pulse comes from is one thing, but knowing causes it is another question entirely. For years, the leading hypothesis was that as powerful ocean waves slam into the continental shelf in the Gulf of Guinea, the unique geology of the seafloor acts like a massive drum. The relentless pounding of the waves generates a rhythmic pulse that travels through the Earth's crust. The fact that the pulse intensifies during storms when waves are stronger gives this idea some serious weight. However, as of 2023, a new contender has emerged and is now considered more likely by some leading researchers. This theory points to volcanic activity. The origin point is suspiciously close to a volcano on the island of São Tomé. More recent studies suggest the process could be like a giant musical instrument. One team of geophysicists even compared it to a 10-kilometer-long clarinet, where gas escaping from the Earth's interior is forced through a massive volcanic conduit, creating the steady hum. While this volcanic model is gaining traction, the mystery isn't fully solved, and the debate continues. It's a beautiful reminder that our planet is a living, breathing entity, with subtle rhythms we're only just beginning to understand. But not all of our planet's hidden vibrations are so gentle. Some deep tremors are a totally different beast, and carry warnings of impending disaster. These are known as deep tectonic tremors, and instead of a faint, regular beat, they're sustained rumbles deep within the Earth's major fault zones. They are the sound of the planet's colossal tectonic plates in slow, grinding motion. We usually think of earthquakes as a sudden, violent break, but deep tremors tell a different story. They are the signature of something called slow slip events. Imagine two massive sections of the Earth's crust trying to slide past one another, deep underground. Instead of jerking forward, they creep, moving gradually over days, weeks, or even months. This slow, silent slide isn't something you can feel on the surface, but it generates a continuous, low-frequency rumble that our instruments can detect. These slow slip events and their tremors have been recorded in some of the most dangerous fault zones on the planet. They're a regular occurrence deep beneath the Cascadia subduction zone, a 1,000-kilometer fault running from Northern California to Vancouver Island. They're also found in the roots of the infamous San Andreas fault in California. This discovery has completely revolutionized how seismologists see earthquakes. A slow slip event deep within a fault doesn't relieve all the stress. In fact, it can do the opposite. As one part of the fault slowly slides, it can transfer that stress to other segments, particularly the shallower, locked portions. It's like slowly tightening a spring. The slow slip events in the Cascadia subduction zone, for example, are believed to be loading stress onto the locked section of the fault, where a devastating megathrust earthquake is expected in the future. For over 300 years, this stress has been building, and each slow slip event may bring it closer to its breaking point. For decades, the holy grail of seismology has been to reliably predict earthquakes. Historically, it's been considered an impossible problem. We have probabilistic forecasts, but that's a far cry from a true prediction. However, the study of deep tectonic tremors, combined with the power of artificial intelligence, is bringing us closer than ever. Scientists are now using AI to listen to the Earth in ways we never could before. These AI models can sift through enormous amounts of seismic data, detecting tiny tremors and patterns invisible to human analysts. Christopher Johnson, a scientist at Los Alamos National Laboratory, says AI has revolutionized their ability to find small earthquakes that are typically lost in the background noise, faint signals that contain vital clues. A groundbreaking approach from researchers at the University of Texas at Austin involved training an AI on a 5-year database of seismic recordings to recognize subtle changes that preceded past earthquakes. In a remarkable 7-month trial in China, the AI managed to correctly forecast 70% of earthquakes a week before they happened. It successfully predicted 14 quakes, getting their location to within about 200 miles, and estimating their magnitude with impressive accuracy. Now, this is a monumental step, but the system isn't perfect. It missed 1 earthquake and gave 8 false warnings. Still, while this single study needs more replication, a 70% success rate has the potential to save countless lives. Other AI systems, like QuakeFlow developed at Stanford University, use machine learning and cloud computing to process seismic data with incredible speed. This system can identify thousands of small tremors that standard techniques often miss, providing a clearer picture of what's happening deep underground. The ultimate goal is to combine these data-driven AI models with our physical understanding of how faults work. We may not be able to predict every earthquake just yet, but the science is clear. The deep, silent tremors of our planet are no longer just noise. They are data, and by learning to speak their language, we are on the verge of solving one of nature's most terrifying mysteries. The journey into Earth's deep tremors takes us from a beautiful rhythmic mystery to a world of hazard prediction and cutting-edge technology. So what do you think is the cause of the 26-second pulse? Let us know in the comments below. And for more explorations into the incredible science of our planet, don't forget to subscribe. From the steady metronomic heartbeat in the Gulf of Guinea to the low rumbles that signal the grinding of tectonic plates, these vibrations paint a picture of a planet that is dynamic and very much alive. The 26-second pulse remains a symbol of the profound mysteries still hidden beneath our feet. At the same time, the once puzzling deep tectonic tremors are now being decoded, offering us a powerful new tool in the quest to forecast earthquakes and protect communities. Science is a process of continuous discovery, and by listening closely to the deep rumbles of our world, we are getting better at understanding the secrets it has to tell.